In today's lecture, we will discuss about Reeving system and how we are able to get the mechanical advantage using the concept of Reeving. So in this lecture, we will discuss about this. Okay. So before going further, we must first understand what is the basic principle, how this Reeving system originated. So if you have seen the tube well from which in the villages the water is being lifted up from the tube. So this is basically the simple system over here. Okay, the tube well system basically. If you just make the FBD of this well system, so it is something like this. Okay, so what you are seeing over there, there is one pulley. On this pulley the number of wires are round in the rounding tied up basically, and there is one end, and this suppose this is the bucket, and this bucket is having the weight mg, and there is one reaction frame. These is basically reaction frame over there. Okay, and when the load or the effort is equal to the weight of the object, then just this start lifting up. You just withdraw water from the well. So this is the simple system. So what we analyze from this, the effort depends upon the number of wires. We will understand what I am saying later on. And the second thing is that there is one reaction frame that is being required in order to distribute the extra additional forces that is being generated. Okay, there is one reaction frame over there. Okay, so this is the reaction frame. If we make the video of this reaction frame, so this reaction frame part is under bending, having the bending forces, and this part is basically under compression. Okay, so what we have understand, if any lifting system we want to deploy this system, we want to use this system, we must first have a pulley. Okay, and the pulley, and there is one reaction frame in order to take the external or the reactions during the lifting. We require this thing. Okay, this is the simple idea that we get from this system. Okay, now we will understand about this wire rope hoist system. So this wire rope hoist system, whatever is over there, it is simple. There is a drum. On this drum a number of wire ropes are being there, and tied over there, and they are being it is like this system only, winch wire rope system. This is a system over there. There is a continuous wire over there, and these drums are being operated through motors or the machines. That is basically the winch system. Okay, so this is simple thing. These wire rope hoist system or the application is being used in all lifting equipment, cargo handling, marine application, mooring and anchoring, material handling, ropeway, transmission line. In the last video I also show you when this ship is being parked up, there is a platform that is being lifted using these winches, a number of winches. Okay, so there are many application and number of application of wire rope system. So what exactly is reeving system? A reeving system is a rope system in which wire rope travels around winch drums and sheaves or pulleys for the purpose of lifting and pulling. So the purpose is not only lifting and pulling, they also have a target in to reduce the effort. Basically we have to increase the mechanical advantage. Okay, and effort less. So what exactly mechanical advantage? Mechanical advantage is just simple thing. What you are lifting up, the weight that you are lifting up, and the effort you are applying. Okay, that is basically mechanical advantage. More is the mechanical advantage, less effort you have to apply in order to lift the load. Okay, so we will understand simple cases and and get to know what exactly is reeving and what is exactly part line. What are part line basically? Okay, this is the reaction frame. This is the simple case is like this. We are pulling something up, and there is a rope passing over this pulley. There is one reaction frame, and this load is being lifted up. So whatever the tension, if I try to lift it up, the tension will be equal to the weight of the object. So here the tension is equal to the weight of the object, and this object is having a weight of 100 kilonewton. So the load is 100 kilonewton. Okay, so the load coming on single rope is there, or the single wire rope is there. So the load is coming on the single wire rope is 100. So in such a case, the part line is equal to 1, and if we calculate mechanical advantage, the load we are lifting is W, and the effort we are putting up, it is also W. That is equal to 1. This is a simple case. Now we move on to the second case. This is the second case basically. Now we are lifting up, we are putting effort over this. Okay, effort is lifting up, we are lifting from this side. Okay, the person is lifting from this side. Now this load, if we draw the FBD, these two rope wires are over there, and this load is being lifted up. Now this load is being lifted by two wire lines. Now the load is equally distributed on these two wire lines basically. Okay, this is the traveling pulley block over there, and this is simply lifted up. We are lifting up using the number of part lines is 1 and 2. There are two part lines. In such a case, mechanical advantage is equal to 100 kilonewtons of weight we are lifting up. Okay, but on each wire rope, what the weight effort we are putting up on this is only 50, half of that. So mechanical advantage is 2. So what we are seeing up, mechanical advantage is generally the number of part line. Basically the number of lines we are able to provide, the mechanical advantage keeps on increasing. So this is the simple funda over there. Okay, now the another case is type 3 case. Here the same, it is like same, but there is some modification. Here one end is fixed to the pulley. Okay, this is upper pulley block is there, and where here it is used like this crane system like this. Is there are two pulley 1 and pulley 2, and one end of it, this is fixed to this and wrap around this and then wrap around this, and we are lifting up this like this. Okay, so here the again, but it is just a modification. Here the two pulley blocks are being used. One is lowering up and the another is there. Okay, here the only one pulley block is being used. Okay, in order to reduce the reaction forces basically. So there are two pulley blocks are used, upper pulley block and lower pulley block. Here again the load is being supported by 1 and 2 part line, again 50. Again here the mechanical advantage is 2. Okay, so in this way, by increasing the number of rope lines, we can increase the load, that is mechanical advantage. And this mechanical advantage increases, so the capacity, the machine, the power required by the machine in order to lift it up, the effort is basically reducing up. Okay, so in such a case, here I am swing up, just check here, the effort is like this, the mechanical advantage 1. So you can check here, we are using the 3 wire rope line, the mechanical advantage is 3. Okay, in this way, so you have to analyze how many rope lines are there. Sometimes the system is like confusing, one rope is passing through this, but in case, but it is being supported by 2 load only. Okay, so you have to check for the mechanical advantage. Okay, this mechanical advantage is equal to the number of part line. So same in the case of the crane, we are using the same thing. In the, if we will talk about the crane, we will understand or in detail. If we talk about the crane, there is one hook over there, simple case, there is another hook over there. So if the single rope is passing, mechanical advantage 1. If it is passing through like this, mechanical advantage 2. If it is passing through like this, mechanical advantage 3, mechanical advantage 4. So whatever the load is coming, hook load plus block load, okay, we have to calculate both load. So hook plus board, for example, mechanical advantage is 4 over there. Okay, so hook plus block weight is x, then on each wire the weight is coming up x by 4, and mechanical the whatever the load is w, and the effort we are applying up it w by 4. So this is the base, simple, you can understand. Okay, now we will understand how some calculation regarding it and some understanding the conceptuality regarding this. Suppose there is a person, we have to draw this person using a man basket. We have to lift this person using a man basket. Okay, and this is the man basket. This person weighs 60 kg, and this is a man basket which also weighs 60 kg. Okay, so maximum weight w1 is the person 60 kg, and the man basket is also 60 kg. The total weight including this basket plus man is 120 kg. Okay, and this is the system we are using up. There is one upper pulley and there is one lower pulley, and 2 lines are over there, 2 lines passing over there, 2 round, then there is one third round, there is fourth, fifth, 5 rounds I suppose use, and this is the effort, the other person is pulling it up so that it can be move up. Okay, this is a system, and the wire rope system that we are using is like this. There are 1, okay, 1 2 4 3 5 is there, 1 is there, 2 4 is there. Okay, the total number of part lines are 5 part lines are being used. So if the weight, total weight that we are lifting up is 60 plus 60, that is equal to 120. Number of part line is 5. So the effort we required is 24 kg. Okay, in this way. Or the second way, we are calculate using mechanical advantage is equal to total weight by P. So mechanical advantage comes out to be 5. So you have to understand, in the case of the crane, this part line plays a major role. Suppose we have to lift a weight w, we have to lift a weight w, and this weight w is being lifted using 8 part line. Okay, 8 part line we are using up. Now we know the wire rope. 8 part line means 8 wire rope is assisting. 8 wire rope is assisting. So we know the breaking strength of single wire rope. Single wire rope. We know the breaking strength. Okay. Now by taking the single wire rope breaking strength, taking the factor of safety, we can decide what the load is coming on the single wire rope. Okay, and accordingly, depending upon the weight, we can decide the number of part line. Understanding the number of part line is critical. We doesn't directly depend on the operator only. The operator sometimes know, but we being engineers, we also have to check regarding the part line. Hope you like this lecture. In the next lecture, there is one thing, the effect of friction on these rope pulley, because when the wire is passing through the rope drum, there will be a friction over there. Even there is a weight of this rope, so we will understand the effect of friction. What is the effect of friction, rolling friction over there? Okay, so in the next lecture we will understand this. Hope you like this lecture. Keep supporting, subscribe. Thank you.